recurrence formulas from sequences that you have right in front of you. So for example, 3, 7, 11, 15. Okay, well you imagine just being a year 8 or year 9 and you just find the pattern. So for example, the pattern here is that, what is plus 4? And what you do is you state some facts. So 3 plus 4 equals 7. Or 7 plus 4 equals 11. Now, the whole point of algebra is that it enables you to talk about loads of examples at once. So, I'm now going to use algebra to refer to what's going on here. I'm saying that the third term is equal to the second term is equal to the first plus 4. And I'm going to say that the third term is equal to the second plus 4. And the, 18th term plus 4 would be equal to the 19th term. You just spot that that's always one more than that, and just continue with some more examples. Now, just writing those out is not what they want. They want you to use n because I've got 3 examples here. The whole point of algebra is to talk about a whole bunch of examples at once. So what you do is, you just think, how did this become this? But instead of writing that, you write where it came from. When 1 became 2, you were adding 1. So, a better version of this is this. I know it's a 2, but it came from adding 1 to that. See how I've written that. What about this one? T18 plus 4 equals 19. Yes, that's right. Where did the 19 come from? It came from adding 1 to 18. And just one final example, this one here. T2 plus 4 equals, I know it's T3, but that came from adding 1 to 2. So right, adding 1 to 2. This thing here is called the not doing the arithmetic technique. Instead of actually writing the number, you write where it came from. So instead of 19, you write 18 plus 1. In other words, you don't do the arithmetic. You just leave it as 18 plus 1. And what you do is, you look down and you think, which things are changing depending on the example. This plus is not changing. This 4 is not changing. The equals is not changing. The t is not changing. That little plus 1 is not changing. Anything that's not changing will feature in your answer. And anything that is changing, you name that n. Because the whole point of algebra is to talk about a whole bunch of examples at once. And that is your recurrence formula. It's just an algebraic expression of all the particular examples. I'll give you another example. So, let's say, I don't know, 3, 6, 12, 24. What's doubling here? So, you write down some examples. The second term is equal to 2 times the first term. The fourth term is equal to 2 times the third term. Just continuing the pattern. The 10th would be equal to 2 times the 9th term. So, how is that coming from that? It's coming from adding 1. So here's a better version. Here's a better version of that. Here's a better version of that. What's going on here is that instead of writing the 10, I'm writing where it came from. It came from adding 1 to the other one. Now, the whole point of algebra is to talk about the same example over and over again. We don't need algebra to refer to those. That 2, that equals, that t, they're just part of the basic look. That t is as well, that plus 1 is. Algebra is to talk about these examples. So you just name them n. And there you go. That is your recurrence formula.